Welcome. In this video, we will be giving you a brief introduction to Azure Machine Learning Studio. Now, in order for you to be able to follow this video, I assume that you have a basic understanding of machine learning. For instance, you know that in machine learning, we train a model on some training data and then we test it on new unseen data. Now, regarding the pronunciation of this tool from Microsoft that we are using, the pronunciation is somewhat controversial. US people tend to say Azure. British people, on the other hand, they tend to say Azure. Here I am using the latter pronunciation, but both are correct. In this video, we have the following learning objectives. We will sign into Azure Machine Learning Studio. We will create a new experiment. We will add some sample data sets. Please note that a lot of the data sets we already use in this course are already provided by Microsoft Azure, and we can simply add them from their platform. We will then open the dataset, visualize some important variables, either through a histogram or a scatter plot, and then conveniently Microsoft Azure already provides estimates for the mean, median, minimum or the maximum, and the standard deviation of all variables in our dataset. We can also check variables if they have any missing values and what the variable type is. We will then continue to investigate the typical structure of an experiment workflow, or to state it otherwise, how a common process looks like when we work with data and try to learn some pattern from the data. After that, we will explain to you what modules, output and input nodes are. Finally, we will investigate on how to add a custom dataset from a local file, such as a CSV file. Let's head on to sign in to Microsoft Azure. We can do so by entering the internet address studio.azureml.net. We can sign up for Microsoft Azure Studio by left-clicking on the blue Sign In button. We do not need to register a new account. You can simply use the account provided to you by the university. We can now select an account and we can enter in our email address on the top and our password on the bottom. This is the main screen when we land on the starting page of Microsoft Azure Machine Learning Studio. In your case, it will be blank because you're logging into Azure for the first time. But I already went ahead and created a couple of experiments to show you some functionality. In this experiments section, we see our prior created experiments. And if we click on them, we can see an overview of what the experiment looked like. An experiment is simply the collection of steps we need to undertake to get from our raw unprocessed data to our final model. Now, how can we add a new experiment? Under the Experiments tab, we can add a new experiment on the bottom left by clicking New. We can then open a blank experiment. This will give us a blank experiment, which we can give a name to on the top if we choose so. Now, here we can drag and drop in different modules. Modules is either the data set or various operations such as cleaning data, handling missing values, or performing machine learning steps, which we'll consider afterwards. Let us start with trying to read in the iris dataset, which we already introduced in the last video, classification intro using iris data. To do so, we can go on the Saved Datasets tab. Under My Datasets, this would include datasets which we uploaded from a local file. Under Samples, Microsoft Azure provides us with already uploaded datasets. Now we can choose from this list the iris dataset, which is the iris 2-class data. Now we can drag and drop this dataset into the blank experiment. This is our first module. Let us now investigate our data. We can do so by right-clicking on this one. This one here, this is called an output node. So an output from this iris 2-class dataset. So we can right-click on this one and click Visualize. This will give us an overview of our dataset. At first glance, we can see we have 100 rows and 5 columns. The first column is the class. So this is the variable indicating which kind of flower it is. We then have 4 explanatory variables, also called features. We can then click on sepal length, for instance. Here on the right-hand side, we are presented with a bunch of summary statistics, such as the mean, median, minimum, maximum, and standard deviation. We can also see the number of unique values of our 100 data points of sepal length. So we can see of these 100 sepal length observations, there are 33 distinct values. If our data series would have any missing values, this would be indicated by this row. So we can see in the iris dataset we don't have any missing values. Now the feature type is also of importance, since we need to treat numeric and categorical variables differently. Categorical variables are, for instance, the gender, so either male or female, and we need to code it differently when performing machine learning exercises. In our case, with the iris dataset, our 4 explanatory variables all contain numbers, which makes them a numeric feature. Now, what we also can do to get a better understanding of our data is to do some charts about the distribution of some variable. Now, for instance, for our sepal length variable, we can make a histogram. This is provided already by Microsoft Azure. So here we see for our variable sepal length, between the values of 4.3 and 4.66, there are 9 occurrences. What we can also do is a scatter plot, where we compare one variable to another variable. So let us, for instance, compare the sepal length variable with the petal length variable. We can do so by left-clicking on this menu and selecting the petal length variable. What we get here is a scatter plot, which shows us for each value of the sepal length variable what the corresponding value of the petal length variable is. Now, before we set up our own very simple experiment, let us recap the cross-industry standard process for data mining. The first step is always to understand our business. Then we can collect some data or use existing data. We need to understand our data. Based on that, we can do some data preparation, which includes constructing new variables out of existing ones, or handling missing data, deciding what we do with our missing data, either drop it or replace it with some other values, such as, for example, the mean. Then we can proceed on with the modeling step, where we choose some kind of model to try to learn a pattern in the data. We then go on and evaluate on how good the model is. And depending on how good the model is, we maybe need to go back to the start and question ourselves, have we forgotten an important variable for example, which we didn't measure? If our model is good, we can deploy it. Now in Microsoft Azure, this is all done via the experiments workflow. We also start with the data in the beginning. Then we go on to doing the data preparation. As I already mentioned, this can, for example, include cleaning missing data. Now, in our example of the Iris 2-class dataset, we are very fortunate. We already found out we don't have any missing data. So we can go on with the modeling step. The modeling step includes first to split the data. Splitting the data means that we create two partitions, for example. One of the partitions will serve as a training data set, and the other partition will serve as a testing data set, also known as a validation set. The purpose of these two partitions is that we want to fit the model on one data set and then test it on another data set. If we don't follow this procedure, it is very easy to overfit and to have a poor fit on new data which the model has not seen before. The train model step is where the selected algorithm will go through the dataset trying to learn the pattern. The algorithm in this example is just a 2-class logistic regression. We can choose from a couple of different ones, which we will see in the Microsoft Azure platform. The next step is to score the model. This is where the trained model is exposed to the validation dataset to make predictions on the unseen data. Finally, we want to evaluate how good our model actually is. This is done in the Evaluate Model module. It is used to calculate a set of common model performance metrics. Now let's set up our own very first Microsoft Azure experiment. We already imported the data. This is the Iris 2-class data module. These boxes are known as modules. We already talked about the output node. Since we don't have any missing values, we can carry on with splitting the data for our machine learning exercise. The fastest way to find the split data module is to type in split data in the search bar. We can then drag and drop the split data module beneath the data module, and we can connect them using an arrow. We first have to click on the model from which we are connecting. So this is the data module. And then we left click on the output node of the data module and connect it to the split data module. This is also known as an input node, where we give this data set as an input to the split data module. Now, if we click on the split data module, we see here that 50% is the fraction that goes into our training or testing set. We can specify this to other values, such as a 70-30 split. This would mean that 70% of our data goes into estimating the model, and 30% of the data is exposed then to our estimated model to evaluate how good our model actually is on unseen data. Note that at the split data module, we have two output nodes. The first output node gives us the data for training the model. The second output node gives us the data to test the model. Let us now get the train model module. We again type in train model into the search bar, and we simply drag and drop the train model module. We then get our training data set, so that is from the first output node, and connect it to the input node of the train model. Note that we have two input nodes. One of them is green. That means you can connect it. If it's red, you cannot connect it. The input node on the left-hand side was red because it wasn't intended for a data input. Instead, it is intended for an algorithm which we want to choose to train our model. Now, we can type in the name of the algorithm on the top. For instance, we can use a two-class logistic regression. We can simply drag and drop this again into our experiment and connect it with the train module. Now, instead of typing in the name of the algorithm we want into the search bar, we can also consult what kind of algorithms Microsoft Azure actually provides out of the box. To do this, on the left-hand side, we can go to Machine Learning, Initialize Model, and go to Classification, because we only have two possible classes in our data, namely if the flower belongs to one kind or the other kind. Here on the classification, we have a couple of different choices we can make. So the two-class logistic regression is here, for example, but we could also just estimate the neural network. To do so, we drag and drop the two-class neural network inside the experiment. We delete the two-class logistic regression by pressing the delete button and just combining the neural network with the train model module. This would estimate our experiment with a neural network algorithm. But let's suppose we want to choose a two-class logistic regression first. We delete again the neural network, drag and drop the two-class logistic regression inside the experiment and connect it. Now in the train model module, we see that there is a red exclamation mark here. It says a value is required. Now we can click on the module, left click, and we see that we have to select a column. Now this is because the model, it doesn't know which column in our data is the y variable, or which column do we want to predict with our x variables. In our case, this of course would just be the class, indicating what kind of flower it is. You can just select the class here and click the OK button in the bottom. Now let's continue with scoring our model. That means we expose it to the unseen validation dataset. To do so, let's move around the pane here so we can zoom out a bit and type in the search bar score model. Drag and drop it into the experiment. Connect the train model module with the score model module. And now we need to expose the model to the unseen data. We do so by connecting the output node from the split data module with the score model module. The last step is to evaluate the model. We drag and drop the evaluate model into our experiment and we simply connect it. Now you see here we have two green input nodes for the evaluate model module. One of them we just used for our first one, but the second one we can use to test and evaluate the second algorithm against our first algorithm of the two-class logistic regression. And by doing so, we have a nice overview of the results from two different algorithms, which will help us in deciding which algorithm to choose or which one is best for this particular application. Now the final step is to just run our whole created experiment. And we can do this in the bottom by running everything. It finished running and all the steps that were completed are indicated by a green tick. What we can do now is we can check how well the model performed by right-clicking on the output node of the evaluate model module and selecting visualize. This gives us some nice evaluation results on how well our model performed. This, for example, is the receiver operator characteristic curve. And here on the bottom, we see the confusion matrix. We see that our model performed perfect. It was able to classify all flowers correctly. So we just have trained successfully our first model and solved the first machine learning problem. Now, if we want to add other data, which is not included on Microsoft Azure Online, we can simply upload it in the Dataset tab. If we want to add our own data from, for example, a CSV, on the bottom we can press New and click from Local File. So why do we want to upload a CSV file, so a comma-separated value file, instead of just simply uploading an Excel file? The reason is that a lot of computer languages, they are very confused by Excel, because in Excel you can format a lot of cells using colors and annotating and writing in comments. And so the computer, it really doesn't know when you read in the data, in order to process it, which information it should use. And that's why having a standardized format, which is very simple and just includes values, so numbers or text, and separates them just by using a comma, is very fortunate when you read it into different programs in order to process it further. We can then choose on our local folder our desired CSV file and upload it here using the OK button. Afterwards, all the steps remain the same, but just in the experiment, we would need to replace the data module. To do this, we would replace this data module with the dataset which we just uploaded in the Datasets tab. This would be stored in My Datasets, where we could, for example, just drag and drop our own dataset, delete the iris dataset, and connect our own dataset to the split data module. Now the next video you should watch is the detailed example of modeling the iris data using Azure in the classification intro using iris data video. Thank you for watching.